Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework again tonight. We're doing Math 1, Worksheet 6.2. Remember that if you have a problem with a particular problem, each of these problems mirrors the homework problems. So just fast forward to the problem you're having trouble with, and we should be able to help you out. Let's get started. Problem 1 asks us to find the mean, the median, and the mode for the data set, and then explain which measure of central tendency is best. So let's start with the mean. To find the mean, we simply add all the data and then divide them by how many numbers there are in the data set. So this is going to be 6 plus 15 plus 20 plus 18 divided by, there's 1, 2, 3, 4, 5 numbers. So we add those all up and we get 65 divided by 5. And so my mean is 13. Now to find the median, we're going to find the middle of the data. Very important at this point. Don't find the middle here. Put them in order first. So the order is 6, 6, and by the way, 15, and notice then 18 before 20. Now if I want to find the middle, I just start crossing them off from each side. So there's the ends, and so there's my median. My mean is 13, and my median is 15. Now the mode, it helps to put it in order, and you're looking at, is there any data that shows up more than once, or which data shows up the most? And you'll notice here that 6 showed up twice, so my mode would be 6. Okay? Now in this case, if I'm asking which is the best measure of the median, well, I really don't have much of an outlier. And so actually in this case, the mean, the best would probably be, you could argue either the mean or you could argue the median. They're pretty close to each other. So either one could be considered the best. Problem 2 is like problem 1. We're going to find the mean, median, and mode and describe which is best. So first of all, to find the mean, we add up all of the data and divide by how many pieces of data there are. So I'm going to add 3 plus 5 plus 4 plus 2 plus 4 and divide by 1, 2, 3, 4, 5. So I have 3 plus 5 is 8, plus 4 is 12, plus 2 is 14, plus 4 is 18, divided by 5. So my median is 3.6. My mean is 3.6. Now my median means the middle. Now make sure before we find the middle that we put these in order. See, 3, 5, 4 is not in order. So 2 is my smallest, so I have 2, 3, there's 2 4s, and a 5. So if I'm counting off here, 1 on this side, 1 on this side, my median is 4. Okay? Now my mode asks the question, is there any number that shows up more than others? And notice we do have 2 4s, so the mode is 4. Which one would be the best? In this case, I would say the best, since there's no outlier, it's pretty symmetrical, the best would be the mean. Although notice the mean and the mode are the same. But typically we use mode for things that are non-numerical. So I would say the best is probably the mean. Number 3, let's find the mean, the median, and the mode for this data set of average speeds, and then find which one is best for the data we described. So let's start with the mean. Again, the mean we find by adding them all up and dividing by how many there are. So that's going to be 26 plus 59 plus 47 plus 56 plus 67 divided by 1, 2, 3, 4, 5. And those add up to 255. And so divide that by 5. And our mean is 51, sometimes called the average. Then we'll find the median. The median is the middle data point. To find it, though, we got to put them in numerical order. So the smallest is 26, 47, 56, 59, and 67. So if I kind of look at these a little bit, cross there and there, there and there, my median is 56. Now the next one is the mode, and I'm looking, is there any number that shows up twice or more than anything else? And notice there isn't any, so my mode would simply be none. Okay. In this case, which is best? I don't really see 67 and this being, somebody might say, well, 26 is a little bit of an outlier. If you say there's no outlier, then that would mean the best would be the mean. However, if you said 26 is an outlier, and this is a matter of opinion, then you would go with the median. That's the rule we want to keep thinking in our heads. If we don't have any outliers, those extra big on one side or less small side, then we use the mean. Otherwise, we use the median. Number 4 again, price per pound. We want to find the mean, the median, the mode, and decide which one's best. So again, our mean, add them all up and divide by 5 because there's 5 pieces of data. So 40 plus 8 plus 2 plus 5 plus 6, all divided by 5. And so 40 plus 8 plus 2, that's 50. That's going to be 61 divided by 5, which ends up equaling 12.2. So that's our mean. Our median then is the middle number. So we need to line them up in order. So when I line these up in order, it's 2, 5, 6, 8, and 40. And my middle number then becomes 6. So there's my median. My mode, is there a number that shows up more than any other? In this case, there is none. They're all different. So which one's the best? Well, in this one, it's clear that 40 is an outlier. 2, 5, 6, 8, they're all under 10, then we jump up to 40. So when you have an outlier, the best one is going to be your median. Okay? Notice the incredible difference between the median and the mean. By jumping up to 40, my mean actually is a number that's bigger than all of the other numbers except for the outlier. So this is how this mean, with an outlier, the mean gets stretched out where we don't want it to be. Okay? Problem 5 asks us to find the value of x such that the data has the given mean. So you got to remember how we find the mean. The mean, we add them all up and divide by the number, and that gives us the mean. So in this case, if I were looking for the mean, I would add 15 plus 11 plus 18 plus 10 plus x, and then I would divide it by 1, 2, 3, 4, 5, and it tells me that that has to equal 14. So we simply have an equation that's fine. First thing, let's add all the numbers that we know here. These add up to 54 plus x divided by 5 equals 14. So to solve it, let's undo the fraction. We're going to multiply this side by 5 and this side by 5. And so we have 54 plus x, because 5 divided by 5 is 1. 54 divided by x equals 70. And now undo the plus 54 by subtracting 54 from both sides. And we find out that x equals 16. And that's the number that will give us a mean of 14. All right, find the value of x such that the data has the given mean. Remember that mean means I add them all together. So if I'm finding the mean, I'm going to add all these together. 54 plus 59 plus 34 plus 89 plus x. And then I'm going to divide it by how many there are. 1, 2, 3, 4, 5. Okay? And that, it says, equals 51. So there's our equation, and we're simply going to solve for x. First of all, let's add up 54, 59, 34, and 89. And we discovered that that's 236 plus x divided by 5 equals 51. Now let's get rid of the fraction by undoing divide by 5 by multiplying both sides by 5. So as a result, we end up with 236 plus x, because 5 divided by 5 is 1, and that's going to equal 51 times 5 here. That's going to equal 255. So now we undo this by undoing subtract 36 from both sides, 236, and we discover that x equals 19. And there's our answer. All right, number 7 is exactly like 5 and 6. They just throw in some decimals in here to see if they can scare us. But we're not scared tonight. The mean, we simply add them all up and divide by the number there are. So that's 6.6 plus 4.4 plus 9.9 plus 2.3 plus x. And there are 1, 2, 3, 4, 5 of them. Divide that by 5. So when we add up 6.6 plus 4.4 plus 9 plus 9 plus 2.3, that ends up being 23.2 plus x divided by 5. And oh, by the way, this equals 4.8. That's our equation. Now to undo the divide by 5, we're going to multiply both sides by 5. This becomes 1. So we're left with 23.2 plus x equals 24. And now we subtract 23.2 from both sides. I'm going to change that to a 0 to make subtraction easier. And x equals 0.8. Problem 8 is like 7. Again, we're trying to find the value of x, but we have decimals again. So remember that our mean, we add them all up and divide by the number. So 0.8 plus 1.5 plus 3.3 plus 0.4 plus x divided by the number. 1, 2, 3, 4. There's 5 numbers, including x. So when we add the other numbers beside x, these all add up to 6. So I get 6 plus x divided by 5, and I forgot to put down again, both of these equal 1.4. Okay? So let's undo divide by 5 by multiplying by both equations by 5. 5 divided by 5 is 1, so we're left with 6 plus x equals 7. So undo plus 6 by subtracting 6 from both sides, and we get x equals 1 is our answer. Nice round answer. Okay? Problem 9 gives us the scores of 2 golfers, Ann and Chi, and asks us to figure what's their range and the mean of each golfer, and then based on that data explain who do we think is the better golfer. Remember that in golf, the lowest score wins. So let's start with Ann. First of all, her average score, her mean, we're going to find by adding all these up and dividing it by the number. So 88 plus 92 plus 86 plus 89 plus 96 plus 85, and then there were 6 scores divided by 6. So we add that all up, and that's 536 divided by 6, which ends up equaling 89.3. So her average score for those 6 games was an 89.3. Now the range is the difference between her highest score and her lowest score. Well, her highest score was a 96, and her lowest score was an 85. So we subtract that, we find out that her range is 11. That's the difference between her highest and lowest score. Now when we come over and look at Chi, let's find his mean first. Let's add those up. So his score is 91 plus 86 plus 88 plus 84 plus 90 plus 83. And again, he played 6 rounds, so divide that by 6. And you see that that's 520 divided by 6. So his average score is 86.6. So his average score is less than Ann's score. So in terms of average, he's a better golfer. But look at his range. His high score was a 91, and his low score was an 83. So his range was 8. So he was also more consistent. The distance between his lowest and his highest score was lower. So Chi is the better golfer because he has a lower average and he's more consistent. The smaller range means that he is a more consistent golfer. In number 10, we're going to compare two employees, Armand and Tyler. And we've looked at their work history to find out the number of orders that they fill each day for the past 4 weeks. What we're going to do is we're going to look at their mean and their range and compare their data and decide who's the better worker. So let's start here with Armand. His mean, we'll add these together, 22.4 plus 22 plus 33.5 plus 21.3 divided by, there's 4 pieces of data, is going to be divided by 4. So this adds up to 92.2 divided by 4, which equals 24.8. So that's his mean. Now, if we look at his range, his high sell days to his low sell days, you can see that that ends up between 33.5 is his high, and his low is 22. So subtract 22, and we have a range of 11.5. Okay, so there's his average. The mean is his average sales orders that he places, and that's his range between his high and his low day. Now we move over to Tyler. His mean, 6.2 plus 15 plus 50.4 plus 26 divided by 4. So those things add up to 97.6 divided by, again, 4. And his average then ends up to be 24.4. Not bad, not much of a difference, but at this point, Armand averages more orders per day, per week than Tyler does. But let's look at his range just to see how consistent they are. And his high day, Tyler's high day is 50.4. And his low day is 6.2. Now that's a pretty low day right there. If you subtract those, that's 44.2. Okay? So now, if we look at these, we can see that clearly Armand is the better employee. He has higher average orders, but it's not that much higher. But when we look at the range, he is more consistent. On a day-to-day basis, he's about the same. This range here, the difference in his high and low is only 11 sales or orders, whereas here, 44 sales. That's a big jump to go from 6 to 50. All right. I mean, Tyler's a great employee if you catch him on the right day. But as an employer, you want employees that are consistent every day. So we would pick Armand. Problem 11 says a math teacher is looking at his most recent quiz scores, one of his classes, and it says create a line plot for the data, decide whether it's symmetrical, skewed, or uniform, and then if you found the mean and the median, which one do you think would be the greater? Well, in this case, let's start by making our line plot. I notice that my smallest number is 5, and my largest number is 10. So I'll make myself a little number line here. 5, 6, 7, 8, 9, 10. And now we just start going through and crossing them off. So I have a 9, another 9, a 10, a 5, another 10, a 6, another 9, an 8, 7, another 10, a 9, an 8, that should be an X, not an 8, a 5, a 7, and a 7, a 9, a 9, an 8, and a 10. So that's what my line plot looks like. So first of all, is it uniform, skewed, or symmetrical? I notice my high point is here. So definitely this is skewed. It's skewed to the left. All right? So it's skewed to the left. If I were to measure this, it's not in the center. If I were actually to measure these and add them up, if I did my mean, looking at it, because it's skewed to the left, I would expect that my mean would be less than median, because it would be skewed to the left. And if we figure this out, I think I figured out that the mean, and you don't have to do this for the problem, was 8.15, whereas the median here is going to be 8.5. Problem 12 asks us, how do the mean, median, and mode describe the central tendency of a data set? Why are 3 different measures needed? Well, as a hint, I would say consider how each of them is calculated and how they are affected by an outlier. So in one case, they all are trying to find the central tendency. The mean, however, adds them all up and divides, which seems like a good idea for the center, the average. However, if there's an outlier, then it can either overstate or understate the value if it has a large outlier. The median is simply the middle. It has the advantage that it's not influenced as much by an outlier. The mode just tells you which one shows up the most. And sometimes that's good. Sometimes it could be bad. It could be that a low number shows up the most, even though that most of them are higher than that. So they each have their place. You just got to know how they're calculated to know which one is best to use. Problem 13, an error analysis, says that one student said that 10 was the range of this data. Another student said the range was 8. Which student is correct? Let's explain. Well, let's remember what range is. Range is the distance from the smallest to the largest. So if I put these in order, I got 2, 3, 8, and 10. So the distance is going to be the largest, 10, minus the smallest, 2, which is 8. So the second student was correct. The first student just gave us what the biggest number. He gave us the maximum number, not the range. In our last problem, it asks, how is the range of a data set affected by the outlier? We've seen that an outlier skews or causes the mean to be overvalued or undervalued, but what does it do to the range? Well, just as a hint, just think of an example. For example, if I have this one, 2, 3, 4, 5, 6, the range is 6 minus 2 is 4. However, if I just add an outlier to it, the same exact data, but I add a big 20 to it, now notice the range is 20 minus 2 is 18. So you can see that adding an outlier stretches out the range, making it either much smaller, it makes the range much bigger than it should be. All right, that's it for today. Hope you do good on your homework.